in the hazard zone, but we are tracking green for them to clear that, which means we will be moving forward with tonight's launch attempt as the clock continues counting down. We are now at T-minus 31 minutes to lift off from Launch Complex 2 for Virginia is for launch lovers. If you're watching from the Pacific Coast, then launch is set for 6 p.m. Eastern Time this evening, and adjust your time zone to that. If you're tuning in internationally, then you can convert launch timing to your local time zone from 2300 Coordinated Universal Time, or UTC.
As we make our way through the countdown, let me take you through a rundown of our Electron launch vehicle next. Electron is a 3-stage launch vehicle that stands 18 meters or 59 feet tall. The black and white stripes you can see here are a visual effect caused by the rocket's liquid oxygen propellant. Frost forms on the outside of the rocket due to the cold temperature of the liquid oxygen inside the rocket's fuel storage tanks. The black comes from Electron's fully carbon composite tank structure, using material that is lightweight yet strong enough to withstand the pressure of launch. Powering the rocket are 9 Rutherford engines on the first stage and a single Rutherford engine on the second stage. These engines are 3D printed and named after the famous physicist Ernest Rutherford. They were the first engines of their kind to reach space, given that before the Rutherford, no other 3D printed electric pump-fed engines had ever crossed the Kármán line to space successfully. The engines use batteries to power the electric motor behind the Rutherford's rotodynamic pump, and have the same general structure across the first stage and second stage, apart from a larger expansion nozzle for the second stage engine to better operate in the vacuum of space. We have a unique 11th engine on Electron also, called the Curie engine after chemist and physicist Marie Curie. This propulsion system is located within Electron's third stage at the top of the rocket. This third stage is an orbital transfer vehicle we call the kick stage, which carries the mission's payloads to their exact destination on orbit. The kick stage will carry today's 3 Hawkeye satellites to a 550-kilometer circular orbit after Electron lifts off from the pad at Launch Complex 2 on a southeastern trajectory. From liftoff to orbit, the entire mission tonight should be completed within an hour.
We really are so excited to finally be launching Electron from Launch Complex 2, the first of many exciting missions coming to Virginia. This summer, we'll be launching 4 satellites on 2 back-to-back missions from LC2 for NASA for their Tropics mission, a program to monitor tropical cyclones and hurricanes that will help scientists better understand them and ultimately help save lives with earlier and more accurate storm warnings and predictions. To be ready in time for this year's Atlantic hurricane season, each pair of these satellites on these 2 missions need to be placed on orbit one after another and within just 60 days. Luckily, we know how to move fast, and alongside Virginia Space, we built Launch Complex 2 in just 11 months as an indication of that speed we can move at. For the majority of last year, we launched Electron every month, and our fastest launch turnaround in 2022 was just 15 days. Electron is well suited for rapid launch, and it's a capability we are excited to bring to Wallops for future missions, not just for NASA, but for any government defense or commercial small satellite mission that wants a streamlined ride to space. Rocket Lab's VP of Launch Systems, Sean DeMello, led the charge to bring Electron to Virginia, and he has more to say about what it took and why.
Or joining any of our other 9 sites around the world, we have a lot of opportunities for you. Head to rocketlabusa.com/careers for more information on how you can join the pioneers in the Rocket Lab team.
One of the next pre-launch milestones you will see on your screen shortly is Electron's strong back retracting and moving out of the way for launch. The strong back is that tall black structure behind the rocket that provides stability while Electron is vertical. It also includes the umbilical cable connected to the rocket from the launch pad that provides electricity, air conditioning, gases, signals, and commands to both the rocket and the Hawkeye satellites before launch. Now, while the strongback is moving now to be well out of the way when Electron's engines ignite, the umbilical remains attached right until the last moment in the countdown, releasing automatically just as Electron begins to climb.
We're coming up to T-minus 4 minutes to liftoff. A big moment coming up in the countdown, the switch to the launch auto sequence for Electron at the T-minus 2 minute mark. From here, the flight computer on board the rocket takes over the count as our operators in the ICF keep an eye on the rocket's various readings and levels to make sure all is ready for liftoff. The NASA range officials are also keeping a watchful eye over the launch site and launch corridor for today's mission. They're tracking no issues with range, the weather remains clear, and all surrounding areas are within safety parameters. With LOX loading nearly complete, Electron is almost ready to head to space. Let's hand things over to the team at the ICF and Mission Control and listen in on the last few minutes. We'll be back with you shortly after liftoff.
All stations LD on countdown. From now on, there should be no red flags on your critical LCCs. VCON LD countdown.
LD VCON.
I confirm all expected flight computer ASGOs are green.
Confirmed.
Lock auto sequence and confirm.
Auto sequence locked.
Okay, all stations, we are go for auto sequence start at T-minus 2 minutes. LD is go for launch.
Vehicles on internal power. AFTS is green and enabled for flight.
Transitioning logs system into recirculation. Anti-geysering is disabled.
Stage 1 and Stage 2 are pressed for flight.
High flow engine purge enabled. Deluge is active.
T-minus 20 seconds and counting. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Lift off.
Electrons
Beginning
the pad,
pushover.
saving ground systems.
Stage 1 propulsion is nominal.
And
And liftoff of Electron from Launch Complex 2, leaving US soil for the first time and on its way to space up and over the Atlantic
Entered
Ocean.
burnout detected.
All 9 Rutherford engines on Electron's first stage now propelling the rocket
Stage 1 propulsion
at more than
holding
700 kilometers an hour. We are hearing good calls from the teams in Virginia and Rocket Lab Mission Control. A clean ascent for Electron, now nearly a minute into flight. You are looking at
Eco supersonic, approaching
56,000
max Q.
pounds of maximum thrust from those stage 1 engines, but soon they'll be throttling down to support that
HV
pass
battery
to the
discharge
maximum
nominal.
aerodynamic pressure point.
Cleared max Q.
There is the call out. Electron has cleared that first milestone and is continuing nominally. The 9 Rutherford engines on the first stage
Stage
are
1
throttling
propulsion
back up,
holding
and all
nominal.
looks nominal for propulsion there. We are now at 1 minute and 32 seconds into flight, with Electron moving at speeds of more than, or nearly more than 3,000 kilometers
Guidance
an
is
hour
nominal.
now.
The next major milestone will be those Rutherford engines on the first stage shutting off completely, expected to occur at around T minutes 26 seconds into flight. That will happen just before separation of the
Can
first
I
and
make
second
one
stages,
roughly
which then
30
allows
seconds?
the Rutherford engine on the second stage to fire up and continue with the mission to low Earth orbit. The events are called out from Mission Control as MECO, stage separation, and stage 2 engine ignition. Meanwhile, those 9 Rutherford
15
engines
seconds
are
to MECO.
continuing to propel Electron at more than 6,000 kilometers per hour. 2 minutes and 10 seconds into flight of Virginia is for launch lovers.
Miko, confirm.
Stage separation successful.
Stage 2 ignition.
Excellent news there from our launch operators. Electron has had a successful MECO, stage separation, and stage 2 ignition. The next
Stage 2
milestone will be
propulsion is
separation
nominal.
of the rocket's fairing. We do this to lose unnecessary weight once Electron is through the Earth's atmosphere.
Fairing jettison succeeded.
And as we saw from Electron's onboard camera and heard from Mission Control, the rocket's fairing has successfully separated and fallen away, exposing the Hawkeye 360 satellites to space on their way to low Earth orbit. Our first launch from US soil is going great so far.
Guidance is nominal.
Stage 2 propulsion holding nominal.
Coming up on 4 minutes into flight of Virginia
HVB
is for
battery
launch lovers, our
discharge is
33rd Electron mission. The rocket's second stage is now reaching speeds of more than 9,000 kilometers an hour, powered solely by a single space-optimized Rutherford engine. The second stage will take the payload to the height of the mission's orbital altitude before it separates with the kick stage, which will carry on to insert the mission into a circular orbit. Before that, we'll have a few more mission milestones to complete, including a swap of the batteries for the second stage engine shutdown, and then final stage separation. Those events are coming up at around the 6 and 9 minute marks into launch.
Checking in on the clock, and we are just about T plus 5 minutes into the mission. Hearing nominal calls here from our launch operators in Mission Control in Virginia and Auckland. The second stage Rutherford engine is putting out a maximum of 5,800 pounds of thrust
Stage 2
on its way to
propulsion nominal.
delivering our customers' payloads to orbit. At liftoff, the rocket weighed about 13 metric tons altogether. But since it's shed its first stage that stored the majority of the mission's propellant, along with 9 of those Rutherford engine, Electron is down to 1/5 of its liftoff mass, enabling that second stage engine to propel Electron past 11,000 kilometers an hour.
We are coming up to our next event in the launch timeline, what we call the battery hot swap. This occurs on the second stage of Electron for the Rutherford engine, which switches over to a new set of batteries to power its electric pumps once the first pair are almost out of energy. Once the swap is made, the old batteries fall away from
HVB
Electron,
battery discharge
and sometimes
nominal,
we see
approaching hot
those
swap
shiny
in
silver
roughly
packs
30
on the
seconds.
screen as they go. So let's keep our eyes on the screen and listen in for the call that battery hot swap has occurred.
Throttling down.
Hot swap successful.
Battery jettison confirmed.
Our vehicle
AFTS
control
is 8.
operator there reporting that the battery hot swap was successful, and
Guidance
so
is nominal,
continues
2
our
minutes remaining.
Virginia is for launch lovers mission. The second
Still
stage
propulsion,
Rutherford
still
engine
holding
is firing nominally and propelling Electron past 16,000 kilometers per hour with that new high voltage battery discharge holding nominal. That second stage and the Hawkeye 360 satellites are now at an altitude exceeding 300 kilometers. Electron will continue with this ascent for the next 2.5 minutes until we come up on some of our last actions to complete this mission for Hawkeye 360. They include the shutdown of the
HVB
second
battery
stage
discharge
engine,
holding nominal.
followed by separation of the kick stage carrying the payloads so that it can begin its first orbit of Earth before our scheduled payload deployment, expected at around 57 minutes and 18 seconds into flight.
While we're in the second stage burn, let's take a quick look back at the mission so far. So Electron lifted off the pad at 2300 UTC and performed a smooth first stage burn. Our first stage separation events were effortless, as well as the light up of the second stage engine in space to carry on with the mission. You can see it there, moving the mission along at speeds of more than 21,000 kilometers per hour. Hawkeye's payloads will be deployed to a
Stage to
550
propulsion, still
kilometer
holding
orbit.
nominal.
So with Electron now past 328 kilometers altitude, we have another
Entered burnout detect
200
mode.
or so kilometers to go until that final phase of the mission.
Guidance is in terminal, 22 seconds remaining.
SICO confirm.
Stage 3 separation confirmed. Nominal transfer orbit achieved.
And that is SECO and stage separation confirmed. Deployment of the Hawkeye 360 payloads to low Earth orbit is now a step closer with the shutdown of that final Rutherford engine and release of the kick stage into its first
Great job on the
phasing
nominal
path of
orbit,
Earth.
everyone.
The kick stage
Fantastic work.
separated into an elliptical orbit of Earth and will take the next 43 minutes or so to bring itself back around to the mission's nominal altitude of 550 kilometers. As it comes back close to that altitude, the engine on our kick stage called Curie will light up and propel the kick stage and the payloads into a circular orbit at that same 550 kilometer altitude. Once it's on the right path, the
Payload deployment confirmed.
Well, thank goodness, there we go. That was confirmation of Curie ignition cutoff and deployment of all 3 Hawkeye 360 payloads on our 33rd Electron mission. Congratulations, Hawkeye 360, and welcome to your new home in space, all the way from our new home in Virginia. These satellites will form part of Hawkeye 360's radio frequency detection constellation, able to identify and geolocate sources of radio frequencies from space for communication, navigation, and operations. And today's mission has brought the total number of Hawkeye 360 satellites in space to 15, and these 3 are the first to be deployed into their mid-lateral orbit. This mission also now officially brings the count of satellites deployed by Rocket Lab to 155. Now, 2022 was a milestone year for the entire Rocket Lab team across the world last year. A record number of launches with 9 for the year, and our first mission off planet to the moon for NASA with the Capstone mission in June, supporting the Artemis 1 launch with roll-out solar arrays and CubeSat dispensers, and that was just the tip of the iceberg, with this first launch of the new year marking an even bigger 2023. So congratulations to the whole team and to all of our customers and mission partners. We cannot wait to do it bigger and better this year with you.
And a huge thank you to you at home as well for the support and for sticking with us through this broadcast of Rocket Lab's 33rd mission. We're about to end the show here, but remember to follow Rocket Lab's Facebook, Twitter, and Instagram pages for information about our next mission coming up in early 2023. So, for the first time from Launch Complex 2, this is Rocket Lab Mission Control signing off.